Thank you so much. I have to say that coming to the University of Maryland to talk about teaching innovations is like trying to bring snowflakes to Duluth, for those of you who know. And it started snowing about noon yesterday, where I'm at in Minneapolis. And this morning, my husband told me it was still snowing up there. So imagine, I'm delighted to be here also because I don't even actually have to wear my coat, and there's things blooming already. I also want to maybe do something a little bit different today. First of all, let me tell you the story of how I started out. For those of you who have been assistant professors, maybe this will ring true to you. So I got my first professor job, which was wonderful. I mean, I was shocked that somebody was going to pay me to do the work that I love. And then I'm assigned to teach a class. And I literally would spend maybe 100 hours working on the perfect lecture and figure out what jokes to tell and what colors to use. And this was even before PowerPoint. So we were on overhead transparencies. And what happened was that when I would give my exams, the students did really bad on them. And I thought, what is wrong with them? I told them all that stuff, right? They should just be able, I told them that. They should be able to put those things together and apply it and do things. And they would come and tell me, Robin, your exams are not fair. And I thought, how could they possibly say that about me? I'm the fairest person I know. You know what I mean? It was like denial, total denial. So it probably shouldn't have come as a surprise to me that when I got my very first course evaluations as a brand new assistant professor, I was in the lowest 10 percentile of the whole university, right? Which is not a good place for you to be if you want tenure, right? Because even if teaching, value of teaching is said only as lip service, the lowest 10% is not even going to make you to that level. So I began a journey, that started me on a journey of trying to understand how students learn and what I could do to make that better. And that's what I'm going to share with you today. My plan is this, and you really are in control here, so at least in a few minutes you will be. My plan is to start us thinking together about issues of what is it we really want our students to learn. And then I'll get to a point, maybe in about 10 minutes or so, at which I'm just going to ask you what you want to do. Okay, so I'll give you some choices, and then you can tell me what you want to do. Does that sound okay? All right. So I'm still going to stand here because I don't want to waste any time miking myself up. But if we consider what learning means, think about how do you know when you know something, and how do you know when your students know something? If we look from a psychology perspective, what we find is that a psychologist would tell us that when you have really learned something, now listen to this, okay, this is the standard. Can you use it after a period of disuse? How many of my students actually remember transcription and translation and can use it in the next class? So it's really a challenge. And then be able to apply it to a new problem. From a biology perspective, I think this is really profound, and that is that when you learn something, your brain is physically different than it was before. And that is why learning is challenging. It's hard. It can only happen in a person's brain. I can't make it happen to somebody else. I can facilitate happening to somebody else. But genes get turned on. New proteins are made. New connections are made. And that's what learning is, and that's why it's hard to do. So I'm going to give you your first assignment now, and for those of you who are sitting maybe in a small group, I'm going to invite you to move to another group where you can talk. I'm going to give you about maybe 5 minutes to provide your answer to this question, and then we'll debrief in just about 5 minutes. I'll give you a warning when your time is close to being up. What do you want your graduates to know and be able to do by the time they graduate? How should they be different than they were when they come in? So please discuss in your groups. Each of the groups pick the top choice, your group's top choice answer to this question. 10 seconds. Okay, now I want, this is interesting because in the classes that I normally teach, I would just be able to call out a number and call on a team. But I'm going to ask the team in the this corner back here to shout out your answer to that question. What do you want a University of Maryland student to be able to do when they graduate? Okay, they need to be independent problem solvers. Oh, critical thinkers. Pursue lifelong learning. Communicate. Solve new problems. So we could have a very rich conversation here, right? This is, and what's really interesting is that I've asked this question to lots of people. In fact, this is the first question I ask to my students in my class. Only I don't use University of Maryland, right? So, it's very interesting. But basically, what you've defined is you've defined what matters to you. And it's so interesting because in my own teaching, what I thought mattered to me was not what I was actually teaching. You know, I was teaching all about cells and molecules and stuff, but really what I wanted them to do is use that information to do these things, right? So the evolution, my own thinking about this, is that the content is the starting point. It's the raw material for communication, practicing communication, for learning how to learn, all of those kinds of things. Do you want to see what my students say? It's really interesting. This is what they said this past fall in the class. Be ready for more school. They wanted to be lifelong learners. I think that's their way of saying it. Apply knowledge, not just have it. I'll read a couple more. Discuss, look, they said think critically. Isn't that interesting? These are incoming freshmen coming into the University of Minnesota. If you ask your students what they want, they will say the same thing as what you want. Isn't that really interesting? So the question is then, if this is what matters, well, I'll show you one more thing. This is from the Vision and Change meeting that happened about 4 years ago, the National Science Foundation. A group of students were there, and they were wrestling with the same question. And they're saying things like, engage us, challenge us, infect us with your enthusiasm. They're really eager to work hard and go beyond the content if we'll just let them. So where do these things fit in? I know you've all have seen this, but this for us was a really important organizing principle for our course that I would like to talk a little bit about, again, depending on what you want. And that is that how do you have time? You've got 50 minutes, you know, a couple times a week to do all this, help them think critically, communicate effectively, work together as a team, all of these things. When the heck are you going to have time to do it? And for us, the only way to do that is to offload the bottom 2 levels onto students' shoulders. That is, we decided that if it was something about what a biologist knows, they should read the textbook and come to class with that in their head. Now that was pretty revolutionary in 2007, maybe. We did not have videos. We had some practice quizzes that they could take. But the idea is to assume that they can read a textbook with some guidance. We give them study guides and that kind of thing. And then hold them accountable. So on Monday morning, there's a quiz. And they have to take it. So we can assume that they know that information. And so what that gives us is we use all of class time to do the upper parts. Apply information, analyze data, create new materials, synthesize information, evaluate different alternatives. And we can watch them while they're doing it. That's the cool thing. This is where I think, and you'll see in just a minute, I think that there are things that can't easily happen online. And one of it is to watch a group or a student as they're struggling with information and be there in that moment to help guide them, right? To be there in that moment to support them, to help them not be discouraged. And that seems to me to be more difficult to do in an online situation. Okay, so almost done with the talking heads. I always feel very guilty about this. Because here I'm like an advocate for active learning, and what am I doing? You know, it's just talk, talk, talk. But I think it's important to realize that you use the tool that's appropriate. And I don't believe that lectures are evil. I think that it's not usually a place that people can learn. It's a place where people can be inspired. Not always. There are exceptions. So what kind of tools do we have at our disposal to help students think critically, communicate effectively, learn to be an effective team member? Well, sometimes we have classes like this, right? We have challenges that can happen in these kind of classes. There are MOOCs that are coming online. There's lots of different strategies, and one of the things that's interesting, I just want to tell you, and I think I have a slide for this, but if you think about the history of distance learning, and there's a wiki page, there's actually a Wikipedia site that will do this. It started in 1758. There were correspondence courses in 1758 in England. And in 1858, the University of London gave degrees based on correspondence courses. Did you know that? That is like really cool. Because there's technology, the written paper and cheap mail, they were able to send mail for a penny. That was a technology. The next thing that happened, do you know what Edison said about the phonograph? One of the top in education. The phonograph, you know, but the radio, or courses on the radio. I think I'm sorry. So all of these have been tools over the whole history for the last 300 years or so. And I think the online classes, the Coursera-based classes, and others are going to be tools to help us use the methods, the approaches that work. Now, what's something that hasn't changed over the last 300 years? Our brains really aren't any different. We still use the same chemicals. We still use the same connections. We use the same chemicals, neural connections. Our brains are still basically the same, organic. And so what we can do is ask, what are the things that most effectively help people learn? How do people learn, and how can we do that? Okay, thanks. Now, should I use both at the same time? Thanks. So what are some principles of how people learn? What I would like to do is to give you kind of my major take-home messages of how I can apply how students learn. Is that okay? And then we're almost to the choosing point, so get ready. Oh, I was going to show you this. The second best Coursera course I've ever been in is being taught right now by Hank Lucas. And he had me at the very first video, which I don't know if you can see this, where he put his dachshund Frankie up as the TA for the class. He had me at that point. It's just delightful and very, very interesting. So for those of you who haven't lurked on Coursera, I highly recommend this one to lurk into. Okay, so key findings about learning. The person who does the work does the learning. And this is one of the reasons why lectures don't work very well, in all honesty, for learning. There are exceptions, and I'll admit that. It's who does the work in the lecture? Well, I was doing the work. I was spending hundreds of hours over the weekend and staying up all night, and then I'd wake up in the morning. Have you ever done this? You wake up in the morning and you say, oh, I need to change that slide, or I need to add this in. It was all about me. I was the one, my brain was doing the learning. And the best I could hope for is that I would inspire students to go back home and do the learning. So the person who does the work does the learning, so that's part of the toolkit. The brain is social. We still have the same brains we did. So groups of brains almost always can learn better than individual brains. Each brain is unique, and this is a challenge. Every single brain, even if you're identical twins, you have different brains. And the only way you can learn something new, this is really important, the only way you can learn something new is to have existing neural circuits you already have in your brain activated. And so if you're trying to do something that will activate neural circuits in every single brain in the room, you've got a real challenge. Things that work for me are stuff like sex. Everybody's interested in that usually. Events, but anyway, that's my particular toolbox. So each brain is unique. And here's the horrible and wonderful thing too, is that you can't make a memory without repetition, elaboration, and by that it means you have to put it in your own words. You can't, if you've just memorized a phrase that you can spit back on an exam, you haven't learned it. You've got to put it in your own words. You've got to build those neural connections to what you already have in your brain. And sleep, okay? Sleep, you can't make a memory without sleeping. And so for me, and multiple senses are activated. So using what really works means trying to do things that are going to make the students do the work, that are going to activate multiple different kinds of brains, that are going to give them time to repeat. This is one of the reasons we let them have a lot of do-overs, essentially. They can fail at something and have a second chance because that repetition really is good for learning. That's why we give take-home exams, because they can sleep. They can look at a problem and then go to sleep and then come up with different solutions. So here's, there are cases in which there are people who are such gifted lecturers that they can do all that. Somehow they can have students doing the work while they're lecturing. Somehow they can be engaging all the different brains in the room. There are people like this, and Richard Feynman was one of them. I'm not that kind of person. I know it doesn't work for me because students can't answer the questions I want them to be able to answer if all I do is lecture. So for me, using what really works is, am I making the students do the work? Are the students working together? Am I engaging multiple brains and, as much as possible, multiple senses? Can they touch something? Can they write something? Can they listen to something? Can they see something? All of the senses. I haven't figured out how to use smell yet, but that's an interesting one. And finally, are there opportunities for repetition, elaboration, and sleep going on? Okay, so now's the big moment. What I have in my plans here, what I can do, or something else that you might want to do, how can I be useful? I could talk about a classroom in which we've tried to do the following. We've tried to ask, how well can I help my student become a biologist? And by that I mean learn to think like a biologist, learn to solve problems like a biologist. So this class, and the idea is that instead of just being an appreciator of biology, they're actually doers of biology. So the door's open now for you to decide, do you want to learn more about this class that we teach in an active learning classroom space like this? Do you want to learn more about what we do in those kind of active learning spaces? I have some examples of activities that we find really effective in those spaces. Do you want to talk to each other now? What would you like to do? So why don't you talk in your teams for a little while, and then we'll take kind of a mini vote of which direction you want to go. And I'm looking at my time. We have about it's about 15 minutes? Because, yeah, about 15 or 20 minutes for you to talk. And again, ask questions. So talk to your group for just a minute and make a vote. Do you want to learn more about this course? Do you want to see some examples? Okay, I'm not going to give you much time to do this. And I'm going to stand outside this particular lecture. This is pretty much how my classes work, except I don't have a podium to stand on. I'm down there in the ground. So we usually don't give everybody quite as much time as they would like to have, because we don't want them to get off task. So how many want to learn more about the class? How many groups want to learn more about the class? How many people want to see some examples? Okay, all right. See, isn't that easy? All right, so what do you do in a classroom kind of space, in the space? Well, knowledge and understanding, like I said before, that's on students' own shoulders. So we have study guides, they have a textbook that they pay a lot of money for, $250 almost. And then they have self-tests, and then we do these quizzes. But what we do in class, so usually on Monday we have the quizzes, and then we start with application and analysis activities. That is, we might show some data, we might have them work through a problem from the textbook. And a lot of people ask me, well, how long did it take you to figure these things out? How do you figure out these activities? You know what? Remember those lectures that I spent all that time on? Remember that? What I did is I simply said, what are the key things that are important? Not all this content stuff, because they already know that. I used to tell them that. Now I can make them do it instead. So I took my lectures and just converted them to questions, essentially, and asked students to do the work while I was watching them. So these are some of the kinds of things you want to do. And I'm going to give you, I'll start with this example because I think it also illustrates how easy it can be to have pretty compelling activities. Okay? So on your desk, on your tables, there are these forms that you're going to use in just a minute. The way that these are going to work, we train our students to do this without even being told. But what will happen is you can work in groups of 2 or 3 depending on how many are at your table. And that's the team. The team is going to use that, not the individual. So I'm going to put up some questions based on a figure from the textbook that you read. You read this already, right? You all came doing your work today. And what I want you to do is talk together and come up with your consensus answer. And then when you think you have the right answer, just scratch off A, B, C, or D. And if you're right, you'll get a little prize underneath. Okay? So here's the question. There's 2 molecules here, fructose and glucose, combined to form sucrose, right? This is from your reading. And so what happens when sucrose is synthesized? Is it A, new covalent bonds are formed, B, existing covalent bonds are broken and new ones are formed, or C, existing covalent bonds are broken? So talk for just a minute, and then when you have a consensus answer, scratch it off and see if you're right. What should happen is if you picked number B, how many of you picked number B? Okay, you guys got it right. Now, here's the cool thing. Here's the cool thing. Is A correct? Yes. Is B correct? Yes, but which of those 3 are the better answer? B. So now, do you see this? They're having to evaluate. That puts it pretty up close to the top of Bloom, so you're having to evaluate. And then they get pretty mad. Like if you scratched off A, and my students would do this too. If it's like, but that's the correct answer. And I'd say, on the MCAT, you're going to have to be able to pick the best answer, not just a right answer. And so then they're a little bit quieter. So, anyway, what I like using this because when it works, and this is the first time this happened to me, but we'll live with it. When it works, you have that little tiny reward at the end, and often you get a kind of surprise right there, and then there's discussion. And I love clickers too. For lots of things. What this allows you to do is one group can move at a different pace than another group. And so we would have those. So a good way to create activities for active learning spaces is just to take textbook pictures and push them a little further. And I'm gonna go to the last question as an example for that. Yeah, and I brought these things all through the snow to you from Minnesota. Man. So, now, this wasn't in the picture, right? This wasn't in the figure. But now I ask, sucrose, I put sucrose in my coffee this morning. What happened to it? So pushing a little further, and now they mostly get this answer wrong. So the first 2 questions I would ask, they would get mostly right. This answer they get mostly wrong. And now we have an opportunity to start teaching and discussing. So a general strategy, a general flow of a class would be throw out a problem to them, give them a few minutes to talk about it, let them talk, come back with answers, debrief, and why did you pick that, et cetera. So these are pretty easy to do, okay? Application and analysis. All right. Is the student doing the work? Are students working together? Are multiple brains engaged? How many of you already knew, how many of you were chemists? Right? So now you could help because you could be teachers of the others and help them figure it out. How many of you are not chemists? Right? And it's like, holy cow, what's sucrose? It's like, and then opportunities for repetition, not yet. Not yet. Opportunities for sleep, not yet. Elaboration, yes, we could have you debrief why you're choosing those answers. All right, now, I'm looking at my time. I'd like to do one more example, is that okay? And you have a choice of, do you want to do a trick question or do you want to do a video? Trick question? It's a biology question. Okay. So there was an experiment that some people did one time. They put some radish seeds, they weighed them out in a container. So they put an equal weight of radish seeds in 3 conditions: light, with water, dark, without water, and dark with water. Here's a picture, but the person who was doing this experiment got them all mixed up. So which one is which? And I want you to talk in your groups to tell me which one is which and why it's in that order, right? So you have one that weighs more, This one weighs more. This one weighs second most, and this one weighs less. Okay, so talk in your groups, and all the biologists in the group stand up? You are deputized. No, this is serious. Stand up. You are deputized to be my teaching assistants. And what you are honor bound to do is not tell anyone the answer, but help them think about the answer, okay? I kept asking when they were building this building, I said, make the rooms bigger, make them bigger. And everybody thinks I'm insane, but do you see that the minute you have, for example, if this team here, the minute that they get the right answer, they're deputies. So how does one person go around? And the other thing is that there are probably maybe 125 people in this room or something like that. I don't have to talk to every single one. I go over to the 10 tables or so, do you see? So even one person can get around quite a bit and show the love, if you know what I mean. So everybody feels, you know, that they're part. But once you get the deputies, it's like really easy, and it works. Okay, so what made this an interesting question? Were you doing the work? Yeah? Were multiple people engaged? Did you all, even those of you who weren't biologists, were you kind of puzzled by this? Yeah, because it's like there's weird stuff going on. All right, so maybe we'll just do a little debrief. Which is the container on the right? What's going on? What conditions was that one in? Dark with water. And so I'm just going to tell you the punchline, so I apologize. I would never do this to my students. I'd make them go home and look on the web, so I would never do this. But we forget that plants actually have to use energy, not just produce energy, right? They don't just convert energy from the sun to sugars. They have to use energy to grow. And so in the dark, they can't do photosynthesis, but they can respire. They can use their mitochondria to respire. So that's details, but it's kind of fun. Now, I am wondering what you want to do. Do you want to see another example? You know, I'm going to, is it okay if I just choose something for you? Because I think it's something you might want to know about.
What about this was a trick? You said this was a trick question.
Because I've been in rooms in which biology professors choose the wrong answer. 90% of them. I taught with a colleague who's a neuroscientist very well and forgot that plants have mitochondria. It's very common. This is a very, very common misconception. So that makes it tricky. But you know, you can get tricky questions from all over. I think, was it Sam who was telling me this came from an AP? So where did this come from? This came from, I stole it. I saw somebody give this at a workshop, and I just stole it, right? So you can use the textbook, you can just steal good ideas, borrow the good ideas. This is from Janet Branshaw. I get questions from the MCAT, from the licensure, medical licensure. I think maybe the AP exam would be good. Yep, question here? Right, so it's true, but that makes it for me kind of good, because, so the question was, sometimes what's a trick to me is not a trick to them. Usually it's the other way around. I don't think it's tricky at all, and the students think, that's tricky, that's a trick question. So, but you're right, the ideal situation is when you actually have a conversation because people are having different opinions about something. And you can articulate your opinion if you know the right answer or think you know the right answer, but you have to listen and put in the others. But it's right. This is tricky because lots of people get it wrong. So if you have questions that a lot of people get wrong, students will say it's tricky. One other? Okay. Yeah, so that's right, because this isn't a biology class, right? And so and that's a good point, right? If you didn't have an opportunity to do background reading before coming to class, you would be at a disadvantage here. And I apologize, because I teach biology, most of my examples tend to be in biology. So this wouldn't be at the beginning of biology class, this would be later on. What is the right answer? Well, the one on the left are just the seeds in the dark with no water, so that's just the same seeds you start out with. The one in the middle is the light with water, so they're starting to photosynthesize. Yep, so that's and then the other is the other. All right, I'm going to, because I want to be very cognizant of your time, I'm going to tell you one of the best things we did, and it was one of the scariest. I really, really wanted to show you this video, though, I have to say. All right. So we give take-home exams. I'm not going to tell you about that. But the thing that is amazing, if you don't leave today without this message, your students can do way more than you're asking them to do. At least that's my experience. Even non-majors, I learn this continually. I think, oh, I don't know if they can do that. And by George, not only do they do it amazingly well. So let me tell you, we give students real problems. We tell them, we want you to make a recommendation to the president about whether you should invest more money in malaria research or more money in mad cow disease research or whatever. And the students have to research what the disease is, because we don't lecture on it. They have to find out how many people in the world have this disease, how it's affected, how it's treated, and then make a prediction, make an opinion of what to do about that. I'm going to go to this one because this is the one I love. Now listen, this is for freshman biology students. Identify a problem of social value that your team cares about, right? Something you're interested in, and solve it using genes. That's the prompt. That's real biology. That's how biologists think. And we are just amazed at what students do. This group came up with the idea, they learned that there's a certain gene for a protein in the skin that gets turned off when you're 15. And the idea is to make a skin cream that would turn it back on. And that we can talk more about the kind of the deeper, do you notice these are all lovely young women? We could talk more about that. But this group designed a plan for a living camouflage vest that employed squid genes, coloration genes. We've had people develop new breeds of strawberries that will that will continue to ripen after they're picked, because half of the strawberry crops perish. We've had people develop ideas for treating heart disease. Your students can do more than you imagine. So I'm going to end now and take other questions that you might have with this. This is one of my favorite slides. This is the headwaters of the Mississippi River. And what I think of as my job is to help them not just know about the canoe, not just be able to explain how it's made, not just be able to tell me how to paddle. I want them to paddle. I want them in the canoe. I want them to paddle. I want them to learn how to fall out, get back in. And what I found in my experience is where they go will amaze you and astonish you. And it's one of the great privileges we have as educators to watch these students go well beyond even than we thought they could, beyond where they thought they could. Thanks very much.
We have time for a few questions.
The video is an activity we do in class, so sorry. But you can go buy these. It's called Creature Comforts. It's a wonderful, wonderful thing about evolution that has a normal person talking but claymated. It's really cool. So sometimes we'll watch a video and then have them deconstruct it. You know, what might the alien biology be like, given that it's breathing air and that kind of stuff. So I like to do those kind of things.
Did you do it a bit at a time? What would you start with if you were?
Okay, so how do you get to where we are? Well, we started with just lectures, and basically just before the class started. You know what I mean? We would. So it's back to the old time. Instead of lecturing, we would convert our lecture into activities and do that in class. We had the idea of projects, but we didn't trust students to be that open-ended. And so we started with very constrained projects and then watched what happened. So what my best advice to you would be, well, here's the best advice. This is honest. We have data that says that if you teach in an active learning classroom, your students will perform better. So the idea is that it's really interesting. So if you can put a professor in an active learning classroom and not even give them any coaching or tell them to do anything different, things will happen that will improve student learning because it invites different behaviors. So that would be one thing. But I think you start small, and maybe you lecture and you only have one activity. Maybe it's one a week that you have. Maybe you set aside 15 minutes on Fridays that you have some activity. And you see how that goes, and you kind of start until finally you say, well, that's way more fun. It's way more fun for me. It's way more fun for them. They're doing these kind of things. And then all of a sudden, in a couple years, it probably took us about 3 years to get to that point where now, so it takes a while. And the other thing is, the other advice that's really important is that if you don't do a good job telling your students how things are going to be different in this class, you're going to be in big trouble. They are not going to be happy because they know what should happen in class. I sit here, I check my Facebook, kind of tune in. They think they know what should happen in a class. And I think that's another reason why this format is powerful, because when they walk into there, it's not consistent with what they expect should happen in a college classroom.
We have time for one last question. You can.
So my question is kind of a follow-up to that, in that how do you convince faculty that are just so embedded in lecture, and it's, that's the way I was taught, it absolutely works, to just try something new?
Well, this is why I was very encouraged by this result of this study that they did. We have had, in fact, one of our best faculty members, who's one of the most innovative, creative teachers, charismatic teachers I know, was just assigned to an active learning space, and she was mad. She was mad for 2 weeks. I mean, hopping mad. And then it settled, and now she will never teach in another space. So I think that there's some value to just putting people in places where it's easy for things to happen. It's easy to go up to the whiteboard. It's easy to have a conversation. So I think that's what we've found. I would argue it's way easier to build spaces than change culture and...
So
Okay,
I'm going to ask everybody to thank Robin for a wonderful talk and for also modeling what teaching's about.
Thank you. It's really fun.
If you'll turn to